Hey, hello everyone. So actually, before this video, I did one more video, guys. Okay. So in that video, actually, I presented all these Java features, but somehow this file is not visible. Okay. So that's what, again, I'm doing one more video. Fine, guys. So yeah, he will discuss all the Java features. Okay. So I think in the previous video, what we see, guys, I think we learned what is JSC module, what is JW module, and what is Java ME module, right? Java Standard Edition, Java Enterprise Edition, and Java Micro Edition. So now, see, other topics we have in our core Java is Java features. So what are the Java features we have, guys? Okay, simple. Java is a simple. Java is a platform independent, and Java is a architecture neutral and portable, and Java is a secure, and Java is object oriented, and Java is a multi-threaded and robust, distributed, compiled and interpreted, and high performance dynamic. So these are the 12 features available in Java, guys. Okay. Now we will see one by one. Now we will discuss the first feature called simple. Okay. So simple. Okay. So Java is a very easy to learn, guys. Understand? So Java is very easy to learn. Okay. To learn Java, no prior knowledge is required, guys. Understand? To learn Java, no prior knowledge is required, guys. Okay. So everyone can easily learn Java, guys. Okay. So most of the people are saying, right? Oh, Java is quite complex. Okay. No, guys. Okay. Java is very, very, very easy, guys. Easy language to learn. Understand? So, and in order to learn Java, no prior knowledge is required. Let's suppose we have C and C++ languages. If you know C and C++, definitely it will give you some advantage. Understand? But no need in C and C++ knowledge also, okay, to learn Java, guys. Without C and C++ language, we can happily learn Java. Okay. And one more thing. See, if you see in C, so there is a concept called pointers. Okay. So I think those concepts are what, guys, quite complex, right? Pointers. Okay. So the pointers concept, okay, removed in Java, guys. Okay. All the complex features in old languages has been removed in Java. So that's why Java is what, guys, very simple and easy to learn. Okay. Clear, everyone? So that is the call first feature, guys. Simple. Next one. So what is the next feature? Platform independent. Java is a platform independent. So what is the platform independent, guys? Okay. Now, if you write Java program once, okay, we can run the Java program any platform, guys. Okay. Irrespective of platform, we can happily run the Java program. Okay, so this means what Java follows write once, run anywhere principle means write once, run anywhere. Okay, so we'll see how it is. Now, see, if you write any Java program, okay, if you write any Java program, so first of all, we will save that program into by using some file name, guys, in our system. Okay, so after saving that file name, that is what Java source file. We used to call it as what? Java source file. Okay, so in the source file, we have written one Java program. And after that, what we will do, we will save that Java source code, the source file into in our computer. Okay, so that file is called what? Java source code. Okay, so after that, what we need to do in order to execute that, first of all, we need to compile the source code, guys. Okay, we need to compile the Java source code file. So in Java, we have a JavaC tool. By using this JavaC command, okay, we can compile our Java source file. Once you compile the Java source file, you will get bytecode, guys. What we will get? Bytecode. Okay, we use it to call as .class file or bytecode. Okay, so after compilation, we will get what? Bytecode. Right? Now, let's suppose we have I have written one Java file, okay, Java program where in Windows operating system based machine I have written. Okay, and I saved it finally. Let's suppose by using demo.java, this is the file name. Okay, after that, what I did, I compiled it. Once compilation completed, what I got, okay, bytecode I will receive, right? So now I need to run the program, this Java program, okay, to see the output, right? So now to that, what I need to do, okay, so for that, JVM will comes into picture. JVM will take that bytecode, okay, it will convert into, okay, native operating system machine code, okay, native operating system understandable language. Finally, the bytecode will be converted into, okay, the operating system understandable language. So in the machine, we have some operating system machine, right? So let's suppose in the demo.java, I mean in the first, the Java source code, the file, okay, in which machine I have written that file in the operating system, Windows operating system based machine. Let's assume. Now JVM will convert, okay, that bytecode into whom, okay, Windows operating system, okay, understandable code. After converted, then it will execute that, okay, the program, guys. So after execution, we will see output, right? Now, fine. So here we have written the Java program where, okay, in one machine we have written Java program. Finally, after compilation, we will get what? Bytecode. Now we have, okay, Windows operating system based machine and Linux operating system based machine and Mac operating system based machine. Okay, now that bytecode, what I got, can I execute this bytecode directly into Windows operating system based machine? So can I execute this bytecode directly into Linux operating system based machine? Can I execute this bytecode directly into another Mac operating system based machine? We cannot, guys. So we execute this bytecode. What we required, just now we discussed. What we required, guys, JVM we required, right? So JVM, so that's why, so in order to execute this bytecode into Windows operating system based machine, so what we required in Windows operating system based machine, we required JVM. JVM for what? Windows. Understand? This JVM for Windows, okay, we need to add in where? This Windows operating system based machine. We need to install. And this, in order to execute the same bytecode into Linux operating system based machine means what? In the Linux operating system based machine, we need JVM for Linux. Understand? In the same way, for Mac operating system based machine, we need JVM for Mac. Okay, so if you have these JVMs for Windows operating system machine, okay, this JVM for Linux, if you have Linux, if you want to run in Linux operating system based machine, same for Mac operating system based machine, then only you can happily execute this bytecode, okay, this .plus file into Windows operating system based machine or Linux operating system based machine and Mac operating system based machine. Understand? So here in the first Java program I have written, what is the Java source code demo.java. This is the file name I saved finally. After that, in which machine it is? Windows operating system based machine. Let's assume. After compilation, what we will get? Bytecode I will receive. Okay, I have written only once this Java program, right? I have written only once this Java program where I have written, let's assume in Windows operating system based machine. Fine. Now, after compilation, we got bytecode. Now, I have taken this bytecode, okay, from here directly, I'm trying to execute in where? Another Windows operating system based machine. Okay, so I can happily execute this bytecode, okay, which I got from the first Windows operating system based machine, right? I can happily execute that bytecode into where? Another Windows operating system based machine. Why? In the Windows operating system based machine, I have JVM for Windows. Okay, in this Windows operating system based machine, JVM has been installed. Now, this JVM will take this bytecode and it will convert into whom? It will convert into JVM. JVM convert. JVM will convert native operating system understandable code. Okay, guys, understandable code or understandable language. Okay, now in the Windows, after converting from bytecode to native OS understandable language, then JVM will execute that program, and you will see finally output after completion of the execution. Right? In the same way, the same bytecode I can happily execute. I can happily execute to in which machine, guys? In Linux operating system based machine. Understand? Here also we have what? JVM for Linux. This JVM will load this bytecode, okay, and it will convert into Linux operating system, okay, understandable language. Understand? Then it will execute that program. Now here also the same bytecode I can happily execute in where? Mac operating system based machine. Where? So in the Mac operating system based machine also I have JVM for Mac. So this JVM will convert this bytecode into Mac operating system, okay? Mac operating system understandable code. Okay. So after that it will execute that program. Right. So now here see, we have written only once. The Java program we have written only once, but we are executing, okay, multiple platforms. Okay. So write once, okay, run anywhere. Right. Write once and run anywhere. Right. Here see, we are not changing any code in our Java program, guys. Okay, due to these, okay, different operating system based machines, do we change anything here? Do we change our Java program, guys? We did not change anything in our Java program. So we have written only once. Okay, so after that, what? After compilation, we will receive bytecode. Now this bytecode, okay, we are executing where? In Windows operating system also we are executing, in Linux operating system also we are executing, and Mac operating system based machine also we are executing happily. Okay, so this is what, guys, write once, okay, from anywhere. This is called platform independent. Clear, everyone? No, if you see the C language, if you write the C program in Windows operating system based machine, the same program we cannot execute in Linux operating system based machine, guys. If you want to execute Linux operating system based machine means what? You need to write the same the same C program in Linux operating system based machine first. Understand? So that is what C is what? Platform dependent. But here Java is what, guys? Platform independent. Okay, this is very beautiful feature of Java, guys. Okay, Java is what, guys? Platform independent. Once you write the Java program, you can run that Java program any platform. Okay, everywhere, irrespective of platform. Every machine, any machine, irrespective of platform. Clear, everyone? Right? Any doubts? Clear, right? Now we'll go to what? Architecture neutral. Okay. What is the architecture neutral, guys? Okay. So here architecture neutral means, so let's suppose we have written one Java application in one Windows operating system based machine. So by that time, okay, in that machine we are using Windows 9 as a Windows operating system version as Windows 9. Okay, so we have written Java application, fine. After some time, okay, so there is a latest version of Windows came. So we upgraded from Windows 9 to Windows 10 or Windows 11. Understand? Even. So by that time, I am using 8 GB RAM. Now I am using 16 GB RAM. Even processor also I upgraded. Okay. Due to these, okay, this architecture changes, due to these system resource changes, okay, my Java program will not impact, guys. The same Java program we can happily execute after upgradation of these system resources, after upgradation of architecture of system. Okay, the same Java program happily can execute. Okay, so the changes, okay, what we made in our system architecture, those changes will not affect on existing Java program. Due to these system changes, okay, for Java program, no need to, right? No need to, no need to change anything, guys, in our Java program. Understand? Okay. The Java, why here Java program never communicate with system directly, guys. The Java program never communicates with system directly, right? First of all, what we have in Java program, after writing Java program, we have a Java compiler. Java compiler will convert the Java program into what? Bytecode. Okay. After that, bytecode will take by JVM will take that bytecode, and JVM will convert that bytecode into underlying operating system understandable code. After that, it will start executing that Java program, guys. Okay. So here what architecture neutral means what? Okay. So we no need to change our Java program due to system resource upgradation. Okay. System resource upgradation. Clear? Okay. So let's suppose before upgrading our system resources, okay, we have written one Java application, guys. One Java program we have written. Somehow, by that time we have written Java program and we executed the Java program. Happily, it is executing. Fine. So somehow, after that, after some time, okay, we upgraded all the system resources. I mean, architecture of our system, like Windows operating system also, I upgraded from version 9 to 11, and even processor also upgraded, even RAM also upgraded. So now we upgraded, right, all the system architecture stuff. So do we need to change anything in our existing Java program? Okay, we don't need to change anything, guys. Okay, the same existing Java program, okay, will execute successfully even after upgradation of system architecture. This is what architecture neutral. Okay, always our application is Java application is neutral irrespective of architecture changes in the system. Clear? Always our Java program is neutral, okay, irrespective of architectural, okay, system architecture level changes. Clear? No. Now the other feature. What is the other feature, guys? Portable. Okay. So what is the portable? Okay. So I think you people might aware. Okay. You people, I think all the people may. I think all the people will know. Okay. So here, mobile portable. You know, right? Mobile portable. So means what? Okay. So let's suppose I'm using Airtel as a okay network provider. Okay. Uh, network service provider. I'm using Airtel. Okay. Somehow in my residence, at my residence, the Airtel signals are not good, not proper. Okay. Now I want to migrate from Airtel to home Geo. Why Geo signals are good at my residence? Okay. So I want to migrate from Airtel to Geo. Okay. So now in order to migrate from Airtel to Geo, do I need to change my mobile number? Right? No need to change my mobile number. Same number I can use for even Geo service provider network also. Right? The same number I can use for Geo network also. Right? This is called what? Mobile portable. This is what, guys? Mobile portable. Right? The same thing we can apply here also. Right? Now, here I have written one Java application. where in Windows operating system based machine I have written. Okay, so I have written and I have compiled and I executed fine. So in Windows operating system machine, my Java application is what is the application I have written, right? Java application, it is executed successfully. Fine. Now somehow, okay, I want to upgrade the Java application from Windows operating system based machine to Linux operating system based machine. Why? Let's suppose in Windows operating system based machine, we can keep only 6 to 7 microprocessor parallelly at a time. Okay, to increase the speed of the system. Okay, but when come to Linux operating system machine, we can keep 64 microprocessor parallelly at a time. Okay, we can to improve the speed of the system. Okay, comparatively, Windows operating system based machine, Linux operating system based machine is okay, super speed. Okay, understand? So now somehow I have written one application in Windows operating system based machine and I deployed in Windows operating system based machine. But somehow my application is okay, not able to process huge number of requests. Okay, if my application getting huge number of requests, it is not able to process due to what? Speed. Now, okay, I want to upgrade my Java application from Windows to Linux. Why? Linux operating system based machine can process, okay, huge number of requests. Okay, comparatively Windows, Linux operating system based machine is very speed, right? It can process. So that's why I want to migrate. Right now, I can happily migrate, okay, this Java application from Windows operating system based machine to whom Linux operating system based machine or Mac operating system based machine. Okay, so there is no issue. Okay, we no need to change anything in existing Java application code without writing single line, without changing single line of code also. Happily, I can take completely my Java application from Windows operating system based machine to Linux operating system based machine. I can happily migrate. There also my Java application, okay, happily will execute and will happily serve the request. Understand? So here now, converting from Windows to Linux, do I need to change anything in my Java application? No need to change anything. The same Java application, okay, I can use from Windows to Linux operating system based machine. So this is what guys portable. So how this portable feature will achieve? Internally, we are using what? Platform independent feature, guys. Due to the platform independent feature, okay, this we can migrate from Java application one operating system based machine to whom another operating system based machine. Okay, clear everyone? Right? Understand? Now we will go for other feature, guys. Yeah, what is the other feature we have? Okay, Java is a secure. Right. So how can you say Java is a secure? Okay. So first of all, already we discussed, right? Java program never communicate with platform directly. First, it converted into home bytecode, right? First of all, it will convert it into bytecode. Let me write this. Bytecode. Yeah, bytecode by Java compiler. So after that, JVM will convert that bytecode into home native machine code. Okay, native machine understandable code. Okay, now if the bytecode, okay, so that's why Java application what directly will not communicate with the system directly, guys. The Java program. Fine. So that is the one point. The second point. Now, so if you download I mean, anything called, okay, um, somehow, okay, sometimes if you download some softwares from internet, you will see, right? So there is a notification, there is a pop-up, right? So you are downloading the software, okay, it may harmful to your system, okay, want to download or not, like that it will ask, right? So now, okay, that is what guys, it will secure alert, right? Now, if you have dot.class file, right? After executing somewhere, I mean, you have written Java program in some machine, and finally you compiled it. Finally, you got bytecode, right? After compilation, you got bytecode, right? The dot.class file. Now, you will send the dot.class file to another machine through our network. Now, in my machine, I'm downloading the dot.class file. Okay. So if you download the dot.class file from the network, from the internet, okay, you will not receive any notification, guys. Okay. So like that, I mean the harmful, maybe it will harmful to your system like that, right? You will not receive any notification. Why? Okay. So here already we just discussed. So once you receive this bytecode, okay, so who will take this bytecode, guys? JVM will take this bytecode. First of all, JVM will load that bytecode into JVM memory. Okay, to convert what bytecode into, okay, native operating system understandable code, right? So while this process, okay, this JVM will check this bytecode. Okay, so this bytecode is valid bytecode, okay, properly formatted or not. Okay, any human being wrapped this bytecode to spread some virus or not. So like that, it will verify. Who will verify? JVM will verify, right? So internally, okay, there is a bytecode verifier concept, guys, where internally in the JVM, there is a bytecode verifier. Okay, so this one will verify all these things. Okay, if anything is goes wrong over there, okay, it will throw verify error, guys. Understand? It will throw verify error. So due to this, what? Okay, Java is secure, right? So we cannot change. No one can interrupt the bytecode, guys. Understand? No one can interrupt. No one can edit the bytecode. If someone edit also, okay, the bytecode will not execute, guys. Okay, will not execute. Okay, so if the bytecode contains any problem or if it is not formatted properly, then JVM will not execute. Okay, and it will throw verify error. Internally inside JVM, there is a bytecode verifier is responsible to verify the bytecode. Okay, so that's why Java program will not create any issues into system, guys. Okay, so by considering all these things, we can say Java is what? Secure. Clear, everyone? Okay, right? Yeah. Now we will go for next feature. What is the other feature we have? Object oriented. Okay. So Java is a object oriented programming language, guys. So everything in Java, okay, we are going to dealing with, okay, in terms of objects only. We are going to handle in terms of objects only, right? So we will learn, right? Other core Java concept we will see, right? So everything we are going to deal with objects only, guys. Class and object, okay? So we will see, don't worry, right? So now Java provides few OOPS concept, object-oriented programming concepts, guys. So supports, okay? Java supports OOPS concepts, guys. OOPS features, what are those? Data hiding, data abstraction, okay, encapsulation, inheritance, polymorphism, okay, like that we have few features, right? So Java supports all these OOPS features, guys. Okay, so that we can say Java is what? Object-oriented programming language. Okay, don't worry, we will see, okay, in detail. Okay, so this is what, guys, okay, the first six features of Java. Okay, hope you people understand, right? So we will close this video here. Okay, from tomorrow we will see other six features of Java, guys. Okay, so if you like, okay, the content of core Java here, okay, if you like the way of explanation, okay, would you please subscribe my channel? Please like it and please share with your friends. Okay, so here we are going to, I'm going to conduct all the Java full stack related technologies, guys. After core Java, okay, I'm going to upload uh, normal what do you call advanced Java topics, JDBC and servlets. Okay, later Spring, Hibernate. Spring Boot microservices, all these things. Okay, if you subscribe, those videos you will get. Okay, I mean, notification you will receive, guys, when I upload. Okay, please subscribe and please share with your friends. Thank you all.